Welcome, my name is Marco Forte. The title I've given my project is An Application of Computer Vision through HPC with PyCOMPSs, with the theme, What Makes Castles Look Like Castles. I was given a very general brief for my project at the beginning. I just had to develop a sample application with PyCOMPSs, so I decided to use computer vision. What is PyCOMPSs? Well, PyCOMPSs is an application that will turn your sequential Python script into a parallel one that you can use to run on a supercomputer or cloud computing. What is computer vision? Well, essentially what computer vision does is it will automate the tasks that you do naturally with your eyes and your brain. The inspiration for this project was from a paper, What Makes Paris Look Like Paris, from Carl Dorsch et al. In this project, they automatically extracted Parisian elements. Consider the two images shown. How would you distinguish these buildings? Well, as a human, you've built up through natural experience a large catalogue of images, buildings, etc. You were able to combine features in each image to form a classification for the building as a whole. This is what we seek to do with computer vision. A start would be to pick out features in each image that appear frequently in it but not a lot in the other. For example, these narrow arrow slits appear quite often in the castle but not in the other building, or this conical tower top appears only in this other building. There are many other distinguishing features that we could find. How could we automatically extract from a dataset of castle images these distinguishing castle-like features? These are the steps we need to take to automatically find and extract castle features. To find the patches, we apply a technique called the image pyramid and sliding window. You can see this on the right. This lets us get objects at different scales and locations in the image. Next, we need to extract numerical data from these patches. Well, there was possible representations for each image. This is a barracks nearby the BSC. You could use a full color image, but then each pixel doesn't really tell you much about the neighboring pixels, and you can't really get a sense of the shapes and different features in the image. You could use grayscale, which would be handy if you're looking for light objects on a dark background, or you could use color, which would be handy if you're looking for, say, an orange ball in a snowy field. Or we could use something called a histogram of oriented gradients. A histogram of oriented gradients essentially extracts the shapes from the image. It was used by Dalal and Triggs in 2005 for high performance pedestrian detection. Here we see a sliding window searching for an image of a conical roof. We are comparing the patches using the HOG representation of them. You can see this in the bottom right corner. You can see now the detections of a flat tower top also. The idea is very simple. It is almost tautological. Castle features appear a lot in images of castles, but they do not appear a lot in images of castles. Our process is as follows. First, we collect a dataset of 4,000 castle images and 7,000 non-castle images from the internet. We input these and read them in using PyCOMPSs. We extract HOG feature vector and low-res grayscale for each patch using PyCOMPSs. We find the nearest neighbors for each patch, that is, patches that are most similar, and we want to only consider those patches that have most nearest neighbors in the castle dataset. And from there, we do an extra step of training an SVM machine learning classifier that will improve our patches. It takes about 10 to 20 seconds to compute HOG for a 500 by 500 image at 3 different scales and a sliding window. We can really speed this up using PyCOMPSs, so we process the images in batches. Here are some of the results that were automatically extracted. you can see the algorithm did fairly okay. It managed to pick out patches from buildings and was able to ignore boring features like trees and the ground. It's not so good as the original Paris dataset because for multiple reasons. The features in Paris were more common, so each building might have 100 windows or so. They had less variation. Each window of a certain type was very similar across multiple buildings, unlike castles. It's very similar lighting. They took images using Google Street View, which were captured on a single day with the same exposure settings. And images were at more similar angles and scales. Here is the process that we used for visualization. The end result is a map of castles around Europe where we can locate the locations of various features. For example, we could plot a map of the locations of the conical tower tops around Europe. Further improvements, there are many. You could optimize the code better. You could design improved and more appropriate for castles feature extraction. You can optimize the machine learning parameters more. We can do more complex determination of whether a castle contains a given feature in context of the matches. And there's many opportunities for GPU computing.